Hey guys, we're on Unit 4. This is day 7. We're talking about symmetry. And in our warm-up, before we get to symmetry, it's asking us to use the point -5, 3 and find its image after the following transformations, and the grid is optional. So in the first one, it talks about reflecting over the x-axis. So let's go find our point first. So -5, 1, 2, 3, 4, 5, +3 is right here. -5, +3. That's our starting point for every single one of these, okay? And in the first one, they want us to reflect over the x-axis. And so our point is 3 units above the x-axis, so it's going to go 3 units below the x-axis. And it's going to be -5, -3. Okay, remember the rule for reflecting in the x-axis is you actually change the y. Change the y coordinate. Okay, so the 3 now becomes a -3. All right. Next one up, we're going to go back to our original point, -5, 3, and we're going to reflect over the y-axis. So here's our y-axis. And you can see that our point is 1, 2, 3, 4, 5 units away from it. So 1, 2, 3, 4, 5 units on the other side, and this will be our answer. And that's going to be +5, +3. Okay, again, our rule when you reflect in the y-axis is that you change the x. So you can see that our x was -5 and now it's a +5. Okay. Next one up, they're going to ask us to reflect over the line y = x. And so y = x is that diagonal line that cuts through the origin. It goes from the upper left-hand corner of our graph to the lower right-hand corner. Okay, using a straight edge is a little bit easier. Let's see if we can do it though. So this is the one where we have to count diagonally. So I'm going to trace my path. So here's 1 diagonal block, 2, 3, 4. So 1, 2, 3, 4. And this is where we're going to end up right here at this point. And the coordinates of that point are going to be +3, -5. +3, -5. And if you guys remember the rule for y = x, y = x, all it does is flip your coordinates around. And so you're going to have your y come first and your x come second. So if you went up here and you flip these around, 3 would come first and -5 would come second, which is what we got for choice C, or for question C. All right, and the next one, they want us to reflect over the line x = -1. And as soon as I see x equals a number, I think VUX, VUX. Right there, that x is also x equals a number, and it's going to tell me that V is going to be a vertical line. So vertical line at x = -1 is going to look like this. And all I'm going to do is take my point and say that it's 1, 2, 3, 4 units to the line. So 1, 2, 3, 4 units over the line. It's going to end up right here. And again, make sure you go back to your origin to count from. And so that's going to be 1, 2, 3, +3, +3. Okay. All right, next one up, they're going to ask me to reflect over the line y = 2. And when I see y = a number, I think hoy, because this y in hoy is y = a number. And it's going to tell me that it's a horizontal line. You can also graph that in your calculator if you forgot. All right, so y = 2 would be looking like this. And you can see that our point here is only 1 unit above it. So we're going to flip it and go 1 unit below it. And that would be the reflection. Going back to the origin to count, that would be 1, 2, 3, 4, -5, +1. Okay, one last one. And this one guy says that we're going to move it. We're going to slide it. And that 4 means we're going to slide it 4 units to the right because it's +4. And that little -2 means that we're going to go down 2. All right, so if we take our point and move it 4 to the right and down 2, or we can go back up to our coordinates and add 4 and subtract 2. It's up to you. All right. So if I move it 4 to the right, 1, 2, 3, 4, and down 2, I would end up right here. And the coordinates of that point would be -1, +1. And there, our warm-up is done. Okay. Okay, so symmetry. Hopefully you guys know a little bit of symmetry from back in your day when you talked about it in elementary school or in middle school. But a line of symmetry, guys, just like you have a line of symmetry on your body, you have a vertical line of symmetry that you can fold your body on, and your left side of your body would match up with the right side of your body. Lines of symmetry, guys, can go any which way. They don't have to be vertical. They could be horizontal. They could be diagonal. But it's a line that can be drawn through a figure such that both sides of the figure are mirror images of each other. The line of symmetry can be thought of as a reflection across itself that takes the image onto itself. Such a line is also called the axis of symmetry. If you guys remember graphing quadratics last year, parabolas, they had what they called an axis of symmetry that went right through their turning point. Okay, this is an isosceles triangle. It also has a line of symmetry that goes through the vertex right down to the base. There can be more than one line of symmetry in a figure, or there may be none. All right, these are some things that have one line of symmetry: the letter M, the letter E. A whole word can have a line of symmetry if each letter has that line of symmetry, like doc, wow, or upside down, mom. Okay. And this here is an isosceles trapezoid that also has a vertical line of symmetry. We could have two lines of symmetry, like the letter H, or an oval, which is called an ellipse. Square actually has four lines of symmetry: horizontal, vertical, and both diagonals. This here is a circle, which I always think looks like an eyeball looking at me, but a circle has infinite lines of symmetry as long as they all go through the center point. And then there's things that have no lines of symmetry, like the letter F or this right trapezoid here. Okay. All right, I'll see you guys on the back side of notes to talk about more symmetry.